Welcome to this DevTV presentation on the AutoCAD.NET API. This is Session 8, User Interface Elements. After completing this session, you will understand how the .NET API can be used to add user interface elements such as a context menu. You can also customize the AutoCAD Options dialog, and you'll see how to enable drag and drop from a palette. Keep in mind that this session does not cover customizing the ribbon, toolbars, or the AutoCAD pull-down menus. In this session, we're learning about classes in the AutoCAD Windows namespace, not the AutoCAD customization namespace. Another way of looking at it is that we're not covering automating the manipulation of COIX files. Okay, let's go ahead and get started. You can add a context menu at the application level, or you can have a context menu just for certain types of entities. The application level context menu displays when the user right-clicks on the drawing background. You add this context menu using Add Default Context Menu Extension of the application. In this example, you see here, a context menu is being created. The class for a context menu is called Context Menu Extension, and it has properties such as the title. The Context Menu Extension class also has a collection of menu items. Here a menu item named MI is created, and the constructor for it takes a string. And this will be the text that the user sees on the menu item. When the user right-clicks on the drawing background, the context menu will display, and there will be a new item on the menu with the text Circle Jig. When they click on the menu items will display. The menu item will have the text Run Circle Jig, and then when they click on the menu item, the function callback-on-click will be called. You can see that Add Handler is used to control which function will be called. You can also create a context menu that will display when the user right-clicks on a particular type of object. To create this type of context menu, you use Add Object Context Menu Extension. Notice that one of the arguments for this method takes an RX class. In this example, the context menu will display when the user right-clicks on any line in the drawing. In the lab, we will only be adding an application-level context menu. However, it would be easy to change it so it uses the entity as in this example instead. When AutoCAD loads a .NET DLL, it queries the application assembly for an extension application custom attribute. If this attribute is found, AutoCAD sets the attribute's associated type as the application's entry point. This class specified in the attribute will need to implement the iExtension application interface, and this interface has initialize and terminate functions. So we can use this initialize function to set up our application, such as adding the context menu. So our menu will be there when our DLL is loaded. The terminate function will be called when the .NET assembly is unloaded. This will happen when AutoCAD is shut down, as there is not a straightforward way to unload a .NET module. Also, using the extension application attribute can save time when loading a large .NET module, because AutoCAD will not need to check all of the objects in that assembly to find out if there is a class that is the extension application. In addition to searching for an iExtension application implementation, AutoCAD will also query the assembly for one or more command class attributes. If instances of this attribute are found, AutoCAD searches only their associated types for command methods. Otherwise, it searches all exported types, so using this attribute can also save time when loading a large .NET assembly. Here you see the signature for this assembly attribute. We're not using this in our lab, but I just thought I would mention it as it kind of fits with the iExtension application. Now let's see how to use the API to create a context menu by going through the first part of Lab 8. Here you see the Lab 8 Word document. In this lab, there's going to be 3 different sections. First, we're going to make a context menu, and then we're going to extend the options dialog, and the third section will show how to use drag and drop. The steps for the lab are in here. You can cut and paste these into your project if you're doing the labs on your own, or you can use the provided project that we have with this training. This is the way that I'm going to go ahead and do the labs. Here's Visual Studio. Here's the Lab 8 2008 project, and we're in Class 1BB. At the top of this module, you'll see the beginning of Lab 8, and then here is Step 1, and we need to modify our class so that it will implement the iExtension application interface. So we'll type in implements, an iExtension application. When I hit enter, the initialize and terminate functions were automatically added to this class. So I can go ahead and grab those and put those in the right location so the lab steps will work right. So I'm just going to cut these lines of code. I'll just paste them here and then look at the instructions to see where these go. So 23 and 37 need to be inside initialize, and 24 needs to be inside terminate. So here's step 23. Let's paste those in. And then I need to make sure that 24 is inside the terminate. And let's also add the assembly attribute for the extension application outside of the class. So I'll just copy that, paste it in. Okay, that's step 1. In step 2, we want to declare a member variable as a context menu extension. We could just call this something like my context menu. In step 3, we need to create a private procedure named add context menu. And let's put the end sub after step 12. So I'm just using Control X, Control V. We're in step 4. We want to declare an editor variable. Document Manager, MDI active document.editor. Step 5, we add a try catch block. Put the catch below step 11. We put the end try below step 12. Now we're at step 6. We want to create a new context menu. So my context menu is going to equal a new context menu extension. And we made it to step 7, where we can change the title property of that context menu. And we make that equal to circle jig. It's a string. Here in step 8, we declare a menu item. Let's call this MI. That equals a new menu item. And we'll just say run circle jig. In step 9, we need to add the event for the click event for the menu item. We'll use add handler. And then the menu item click event is the object. Then we use address of. put in callback on click is the name of the procedure we'll create. We'll do that in step 20. Then in step 10, we use the add method of the menu items collection to add that menu item of the context menu. So my context menu items dot add, and then we add the menu item. Then we need to use that add default context menu extension of the application, and we pass in our context menu extension. Okay, so let's move along, go to step 12. And here we're just going to do some error handling. We'll just use the editor to write a message. I'll just copy and paste this code in here. If something happens with this code above, we'll get to this catch statement and see an error message. Now in step 13, we need to add a procedure called remove context menu. Private remove context menu. It's a private sub. So let's declare an editor variable. You can use the code from up here. It's the same thing. And then we have a try catch block. Catch below 18 and the end try below step 19. Let's use an if-then statement and test to see if the context menu extension is nothing. So if not, my context menu is nothing, then so we move the end if after step 18. And we can call the application remove default context menu extension. So we need to pass in the context menu extension. And let's make that equal to nothing. And we just want to say a message here. So I'll just copy and paste this code from step 12. Let's move along now and go to step 20. This is where we'll create a procedure named callback on click. Let's put the end sub after step 22. In step 21, we use the using statement and create a variable as a document log. That's going to equal the MDI active document lock document method. Put the end using statement after step 22. In step 22 we call the circle jig function. So now we need to move on to step 23, and that's in the initialize procedure. We're going to call the add context menu. So this will run that procedure when this DLL is loaded. Then in step 24, in terminate, we need to call the remove context menu. And now we can build and netload this DLL to test the lab up to this point. So go to debug, and let's go to start debugging. And I've already set this project up to start AutoCAD 2011. Looks like I'm getting some build errors. Let's go ahead and fix those. So I have the wrong thing set for the event of the menu item. Let me try to build that again. That build correct this time. Alright, now let's go ahead and go to debug and start debugging. Alright, I'm in AutoCAD now. And when I go ahead and right click on the background of model space, here's the context menu that appears, and we're going to load that .NET DLL, and we'll see if it adds our context menu to that menu. On that load, Lab 8 2008. Let me see if that's the right place. Yes. Now right click, and now you see the circle jig command is there, and run circle jig. If I select that, runs that function, and so everything seems to be working correctly. Notice that the command line doesn't return properly, so there's some steps to fix that. But anyway, let's just try that one more time. Circle jig, run circle jig. Let's go ahead and stop debugging. Let's see if we've done all of our steps for this part of the lab. So we have to step 22, 23, 24. And actually this will fix the behavior, step 25. So let's go ahead and try this. So we need to uncomment this DLL import. And we need to add this import system runtime interop services outside of the class. So I'll Control C and then copy that import statement in here. Go back to step 25. And we need to move this after the circle command, this ACED post command. We're going to run the cancel CMD, so this is a way to clean up the command line after running circle jig. So we'll put that right there, and then let's try debugging again. I'll right click, add the circle jig is not there. Net load. Circle jig, run circle jig. And now the command is canceled, and so the command line looks a lot cleaner. So now let's go ahead and return back to the PowerPoint slides and talk about extending the options dialog. The .NET API allows you to add a tab to the options dialog. You do this by using the display option dialog event of the application. In this example, add handler is being used to add a callback to a function named tab handler. When tab handler is called, it will need a user control that will be used for the tab added to the options dialog. On the user control, you would add controls such as a text box that would allow the user to change a setting. The user control also needs a function that can be called when the user clicks OK in the options dialog. After adding the displaying option dialog event, our function will be called when the user runs the options command. In this example, the function is called tab handler, and the function needs to have two arguments. One of the arguments is an object, and the other is a tabbed dialog event args. The add tab function of the tabbed dialog event args is used to add the new tab. You can see that the add tab function takes a string for the first argument. This string will be the text on the tab in the options dialog. The second argument is a tab dialog extension. Notice that the constructor for the tab dialog extension takes a new user control and a tabbed dialog action. The constructor of the tab dialog action takes a function of the user control, which is in this case named onOK. This function will be called when the user clicks OK on the options dialog. In this function, you would get the values that the user put on the tab and set your member variables with those values. Now let's see how to use the API to add a tab to the options dialog by going through the second section in Lab 8. In this part of the lab, we'll add a page to the AutoCAD options dialog. In the Visual Studio project that's provided for you, this user control is already in the project. If you're working through these labs in your own project, you'll need to add a user control, and then you would need to add a text box and maybe a label so that the user knows what this value is for that they're putting in the text box. And then here are the steps for this section. So let's go ahead and work through these steps in the Visual Studio project. So the first thing we need to do is declare a public shared variable as a string. That's in step 26. Let's call this by variable. This is the variable that's going to be set in the options dialog on our tab. Then in 27, let's add a public shared procedure called add tab dialog. And then we move the end sub after step 28. Here we use the add handler, and we want the application, and then the display, use address of and tab handler that we'll create in step 29. This needs to have a couple of parameters. We'll call the first one sender. That's an object. Call the next argument E, and then that's as a tab dialog event args. We want to move the in sub after step 33. So we declare a variable as that user control. And in this project, let's go to View Solution Explorer, My Custom Tab BB. This is what it looks like. We need to declare a variable as that user control. Let's call it My Custom Tab. A new custom tab, so it's a new user control. And 31, we need to declare a tab dialog action. Make that equal to a new tab dialog action. Use the address of and the function. It's my custom tab. OK, on OK. In our lab steps, we're going to add that on OK function. It's not there currently. So in step 32, we declare a tab dialog extension. And the control as object, that would be my custom tab. And we'll pass in our tab dialog to action. And then in 33, we use the add tab method of the argument that was passed in. Name is something like value for custom variable. And the tab dialog extension. Let's move along to step 34. This is just a command method, or a command that called test tab. It'll just see that we can test the value that we get. So we just want to uncomment this write message. So it'll get the global member variable called my variable and just print it out on the command line, and we can set that in the options dialog and then see the changes that we made. So step 35 and 36 are in the user control. I'll view the Solution Explorer and go to the code window for the control, and here you see steps 35 and 36. We need to add a public procedure named onOK. Then we need to make the variable created in step 26 equal to the textbox.text that's on this user control. It's ADSK class. My variable is equal to textbox1.text. Let's go back to the code window for the class. And let's complete these other steps. So we did 35 and 36. So we need to do step 37. So in the initialize procedure, we're adding the context menu before, but now we're also going to add the dialog to the options. So when we load our .NET DLL, it will also add that tab. Let's go ahead and try building this. See if we've got any problems. It did succeed all right. So let's go ahead and run AutoCAD. Let's run the net load. Load our DLL. Run options. And I don't see our new tab, so there's a problem somewhere in this code. Let's go back to Visual Studio and put a breakpoint in somewhere here and see if Add Tab Dialog was called, but it would be called here. Let's see if we get Tab Handler to be called when we run the options command. And our breakpoint's not getting hit, so there is a problem somewhere. Let's go look for that. And I think I saw it. If we look at this code for Add Handler, we see that it's displaying drafting settings dialog. That's not the right event. What we want is the displaying option dialog. So I made a mistake on the which event I was going to respond to. And so let's build this again. Let's debug. Run that load. Then the options command. This time tab handler is being called. And if you look at the tabs in the options command, we see that there is a new tab called value for custom variable, custom value. I can test that value with that command we uncommented. Let's go ahead and look at that. It's called test tab. So if I type test tab, it tells me that the variable was AAA. Let's run the options command again. And change the value here to some other value, BBB this time. And you can see that our value is being set by the user in the options dialog, so it makes it look like it's more built into AutoCAD. Instead of having to have some other place to set your variables, you can actually extend the options dialog. So we'll head back over to our slides and talk about enabling drag and drop, and then come back and finish the lab. You can set up a label on a user control that can be used by drag and drop to automate running a command. To do this, first add a label to the user control and then enable the mouse move event for that label. In this example, the name of the label is called drag label. In the mouse move event, you call the doDragDrop function of the application. The fourth argument of this function is a class that you will need to create that will have a function that will be run when the label is dropped on the AutoCAD drawing. In this case, the class is named myDropTarget. The other arguments are the drag source and data arguments, and these are set to the user control specified by the me keyword. The allowed effects argument is set to all using the drag drop effects all enumeration. The class that is passed into the doDragDrop function needs to inherit from autodesk.autocad.windows.dropTarget and also needs to override the onDrop function. In the onDrop function, you define what happens when the drop occurs. In this example of function, add an int of the ADSK class is being run. Notice that the active document is being locked by creating a document lock variable. The document needs to be locked when dragging and dropping if objects are going to be opened in the document. When add an int is run from the command, like was done in previous labs, document locking is taken care of automatically. Because add an int is going to be opening database object and is not run from a command, the document needs to be locked or an e-lock violation error would occur. The using and in-using statements with a document lock variable will lock and unlock the document. Now let's go ahead and do the last section in Lab 8 to see how to enable drag and drop. In this third section, we'll add some drag and drop support to the palette set that we created in the previous labs. This label is already added in the Visual Studio project that's included with this training. If you're going to be doing this training in your own project, you need to add that label, and then you would need to add a mouse move event as is described in these steps here. But I'm going to go ahead and go over to the Visual Studio project and start with step 38. Here we are in Visual Studio. Show the Solution Explorer, and then here's the user control that was pre-existing, and go to the code window for it. And here's step 38. Use an if-then statement to see if the left mouse button is being used. If system windows.forms control mouse buttons equals Windows Forms mouse buttons left, we move the end if statement below step 39. Here in step 39, we need to call the do drag drop function of the application. Drag source, we'll use me for this control, and we'll also use that for the data argument. We'll just select forms drag drop effects all, and then we'll pass in a new my drop target that we are going to create in the next steps. So let's move to step 40. So here we create a class that will detect when the object is dropped in the AutoCAD editor, and we'll name it myDropTarget, public class. myDropTarget, and this needs to inherit from drop target. That's Autodesk.AutoCAD Windows and then drop target, and it automatically adds our on drop function that we need to override, and we need to put the end class below step 46. Step 41 was done for us automatically, and let's put the end sub below these next steps. So we'll put it below 46. So step 41 is completed. In 42, in the document manager, then MDI active document editor. 43, we need a try catch block. We put the catch block after 45 and the end try after 46. In step 44, we need to lock the document. So we use the using keyword. Let's call it doc lock. Document lock. Need the MDI active document, document manager, MDI active document, and then call lock document. We put the end using statement after step 45. Now let's just run the add init function. In step 46, we just want to add a message in case something goes wrong. So I'll just use this text right here. And that's the end of Lab 8. Let's go ahead and see if this drag and drop will work when we drag that label. First of all, let's build this. Build was successful. I'll go to debug and start debugging. Let's run that load. We'll run our palette command. The palette is displayed. And then let's see if we can drag this label onto the AutoCAD editor. And you can see that it's running the add init. We'll just create a circle. So that functionality is working fine. So again, let's just go through those steps. Drag me label, and I can just drag it onto the editor. That exercise is to show you this functionality of creating drag and drop with the .NET API. That is the end of Lab 8. So let's go ahead and return back to the slides. The AutoCAD.NET API also supports the status bar and the tray. To see the classes for these elements, take a look at the Autodesk.AutoCAD.Windows namespace. Also, if you are going to be using dialogues, be sure to use the Show Modal dialog and Show Modeless dialog of the application. Using the standard Show Dialog or Show methods to display .NET Modal or Modeless forms can cause AutoCAD to freeze or cause some other unwanted behavior. Thank you for watching this DevTV presentation, and good luck with your application development and using the .NET API to add user interface elements like the ones you create by doing the steps in Lab 8.